Choropleth maps are a useful tool for visualizing geospatial datasets, and recently we saw an increased use of choropleth maps to visualize COVID-19 related data, such as vaccination rates. However, this raises the question on whether the patterns conveyed by these maps are a true reflection of the vaccination rates. Here we see two counties with equal vaccination rates of 86%. But if we look at the population of the counties, we see a huge difference. Research has shown that when visualizing data that closely resembles a population distribution, counties with low population and high variance may be shaded darker and may therefore be considered as extreme values, and this could result in misleading patterns. To counteract the challenges associated with population-dominant datasets, well-known techniques such as normalization may be used. Recent research has proposed the use of different metrics such as surprise, and surprise maps show data points that deviate from expected values by calculating an updated belief about the data based on prior knowledge. Therefore, upweighting or downweighting these regions of interest results in a reduced visual search space that masks all data points that fall within a specified range of expectation. However, it is important to note that the surprise metric cannot be interpreted as an event rate. As our research objectives, we consider how the use of different metrics with various map representation techniques influence people's takeaways when conducting analytical tasks and provide recommendations on which map representation techniques are best in practice. Based on these objectives, we overcome the challenges associated with evaluating maps that visualize uncertainty by summarizing map analysis objectives and tasks from prior studies. We designed our study such that participants are randomly put into one of three map conditions that are based on a COVID-19 vaccinations dataset. We therefore conducted a pilot study with 30 participants where we asked participants to respond to two experiment tasks, T1 and T2. However, our initial analysis of the pilot data reflected a high degree of participants' personal beliefs and political affiliation. Using the results from the pilot study, we overcome the challenges associated with noisy feedback by refining our tasks to a sales and marketing scenario. We conducted our main study by randomly assigning 300 participants to one of three map conditions using two different datasets to assess the impact of data characteristics. We also masked the tasks for both datasets to a sales and marketing scenario. To improve the challenges associated with the exploration of maps, we used interaction techniques that allow participants to zoom into smaller regions on the map, and we also provide access to additional metrics through the use of tooltips when participants hover over a county of interest. For this experiment, we were mostly interested in participants' county selections, exploration feedback, as well as their exploration metadata. We used a Kruskal-Wallis test to detect overall effects between participants' county selections across the three conditions. In addition, we summarized the feedback from our open-ended task by identifying keywords such as population, surprise, and color, and lastly, we used a point map to analyze participants' exploration metadata. Quantitative analysis suggests that surprise maps lead people to regions that have high population characteristics, while VSUPs seem to perform similar or better than choropleth maps when identifying event rates. In addition, qualitative analysis suggests that participants only consider a subset of the metrics presented to them. Our point pattern analysis shows differences in county selections on the choropleth map compared to the VSUP and surprise maps. Furthermore, we observe a higher degree of selection consensus on the VSUP map compared to the surprise map. Lastly, we also observe the effect of color and size for all the conditions used in our experiment. Our findings suggest clear differences in map analysis outcomes and support the use of surprise maps or VSUPs in practice. However, future work may focus on effective ways in which priors may be collected from participants and also evaluate the influence of different suppression approaches on people's takeaways when using VSUP maps. Thank you.